this one. So we see a function given to us here. And we suppose that the velocity, so that makes sense, v of t, it's in meters per second, of a skydiver falling near the Earth's surface is given by this function. Time t is measured in seconds. T is seconds. Find the initial velocity, so that would be at 0 seconds, right? So when initial velocity, that's when t equals 0 of the skydiver, and the velocity after 6 seconds. Velocity after 6 seconds, that's when t equals 6. So we don't have to understand so much about this function, just that we're going to plug in 0 for t and 6 for t, and that's going to give us our two answers. So the first one, v of 0 is what we want, equals 51. 1 minus e to the negative 0.22 times 0. Now, we could just enter that in. And what I'm going to show you is the way I'm going to do it saves me from having to re-enter it multiple times. I'll also work through it just, excuse me, so you can see, because what this is, e to the 0 is going to be 1. 1 minus 1 is 0. This is going to be 0. I think so, right? This is 0. E to the 0 is 1. 1 minus 1 is 0. 0 times 51 is 0. So we're going to see that, but wait, it's always good to have more than one way to do something, because then you got to check, right? So that's 51 times 1 minus, or sorry, e to the x is there, so I go second e to the x, and it goes up there, negative 0.22, 0.22. Instead of t, we use x. This is our variable key. Put all of that in, arrow over, put the parentheses. So now this will give me all the values. I just need to go to the table, actually. I could go to the graph, but it'd be easier just to look at the table. When x is 0, look over to the y, I've got my answer. When x is 6, look over to the y, I've got my answer. So I'm going to, because we've been doing other things, go to my table set. It's starting at negative 10. Let's start it at 0, because that's what we need first, right? So that, and then all we have to do is go to the table. So table's blue, hit the blue button, table. 0 is 0, just like we calculated. That's the initial value. So it's starting on the ground, is what that means. No, sorry, back up. What is v? V is velocity. So when he starts, he's not falling, right? That's at time 0. He's still in the plane. He hasn't just going to jump out. He hasn't started falling yet. When he starts falling, my guess is that this is going to be a negative. You could think of it as negative velocity. Its speed's going to pick up. Actually, it should be negative, shouldn't it? It is getting faster. I can see that. Let me just, I do 1 minus e to the minus. Okay, so that's going to get all my stuff right. Sometimes they just, they're looking at the velocity is picking up, the speed is picking up, but it is going downwards. So I don't know. This is, tells us what it is. So when we go out to 6 seconds, we got 37.376, and nearest, round your answers to the nearest whole number. So this will just be 37 meters per second. That's it. And again, we sort of were going through this. I was just talking it, but just, 51 times 1 minus e to the 0. What is e to the 0? Well, that's 1. So 1 minus 1 is 0. And that gives us the answer of 0. So v of 0 is that. Now you could also do the v of 6 by hand, I guess, but there's going to be some point you're going to need to use a calculator. I would, because what is e? E is the number like 2.71 something, minus 0.22 times 6. So that's what we're doing to come up with this. But again, if you just enter in the function as it is to your graphing calculator, you can use the table feature. Just look it up. Plug in the 6, you get this. It's doing it for you. It's plugging it in and doing the calculation. You could also, if you don't have the graphing calculator, yes, we could do it this way. Just plug in this calculation in sort of a scientific calculator rather than a graphing calculator. Either way works. All right. And again, the nice thing about graphing this is that we're actually able to see what's happening. We see the velocity is going to pick up. It starts at 0. It's going to get bigger. I'm going to go with the zoom standard. And we see it looks like it's going straight up. It's not quite straight up, but because of our answers, but I know I need to change my window here a bit. Let's make our Y maximum, I don't know how far to the ground, maybe 150. And then now let's look at that graph. So he picks up speeds. And if you've done anything with falling out of airplanes, if you've done some skydiving, you know, you kind of reach terminal velocity. So it picks up speed, but then it gets to a certain level where you don't get any faster. You hit what they call terminal velocity. And hopefully you get your chute open with enough time to slow you down before you hit the ground. But so that's what that function looks like. Okay. Picking up speed initially. And if we got 1, 2, 3, 4, 5, 6, we will see that graphically we will get this is 37 point something. We can do that. I'll just show you this extra tool. And again, if you don't want to see this, you don't have to. So I go second calc, and it's a value. If you can actually plug in the x value. I'm going to plug in x equals 6, and it gives us the point 37.3761. Another way to see it. I could have plugged in 0, or would have showed it. And what's nice about this is you get the numerical values, but you also see the whole pathway of what's happening. You know, we're increasing, and you know, at 6 seconds, we're getting pretty close to that terminal velocity. 6, 7, 8, 9, 10. Maybe by 10, it's slowing down. But anyway, a way to use the tools to come up with the correct answers, but also the important thing with problem solving and stuff is that you really understand the whole process. And the graph is so helpful in doing that. And that's why I strongly encourage you using your graphing technology, because you see so much, you'll understand so much more deeply. Thanks.